Hello, everyone. My name is Rima Rashidi, and I will present today our paper, which is automatic labeling of tweets for crisis response using business supervision. I will talk about our motivation, what is business supervision, our methods, the experiments, the results. I will discuss the results, and I will end up with a conclusion. So it has been proven that Twitter is a powerful source in analyzing and retrieving information during crises. And when I say crisis, I mean natural crises such as earthquake or man-made crises such as shooting. So during crisis, people seem to share information about their status, the people in need, the injured or dead people, um, and the infrastructural damage, and etc. And this is a result to a huge number of tweets. For example, 177 million tweets has been posted have been posted in one day during an earthquake in Japan. These very valuable information can be used by humanitarian organizations to provide a quick response and make good decisions. However, they cannot use the Twitter or this Twitter data because of the huge number of tweets, and they don't have enough employers to monitor and filter the tweets. So to solve this problem, tweet classification for crisis response has been introduced, which is a text classification task that aims at identifying if a tweet is related to a specific event or not, and this will help in reducing the volume of the tweet. However, this is a very challenging task due to the tweet's nature and the individual judgment. In the literature, deep learning has outperformed traditional machine learning algorithms. However, they heavily rely on the quantity and the quality of the manually labeled data. In our situation, we faced a very serious problem of the lack of manually labeled data. And to solve this problem, some solutions have been introduced, such as transfer learning. So the model is pre-trained on past events to classify tweets related to new events. Uh, However, these models cannot generalize to the new events, and this is because every event has its own features, such as the nature, the place, and the people response. There is another solution which is to add more label data from different locations and class types, and I mean by that to expand the labeled data or to expand the training data. This can be done either by manually labeling the tweets from past events, which is waste of time, effort, and money, or by automatically labeling tweets from past events. But how can we provide the new words or new relations? Can be done by an external source by employing distance supervision. So what is distance supervision? Distance supervision is a method of using existing information sources to label the training data for a specific task. And can be done via external knowledge base, such as tree-based and event extraction tasks, frame net and relational extraction tasks, word net and relational extraction tasks, and etc. And this helps in providing new keywords and new relations to the training dataset. Distance supervision also has been applied for Twitter data. For example, emotions have been used to label the tweet in sentiment analysis. So if the tweet has a happy face, then it will be labeled as happy. Also, account types has been used in topic specific classification tasks. So if the Twitter account is a sport account, then the supervision assumes that all the tweets posted by this account will be labeled as a sport tweet, so they will be labeled as a sport. Um, Also, YouTube video links has been used in topic classification tasks. So if the tweet has a YouTube link, then the title of that video will be used to label this tweet. in topic classification tests, of course. So our method. So this is our framework. Our framework consists of 6 stages. So in the first stage, we use the available annotated data from previous events to create the crisis type keyword list. And that will produce the initial keyword list, which has all the words without any restrictions. And then we select the top key keywords list by using statistical methods. Um, and then that also will end up with the top key keyword list. And then we expand those keywords, the keyword list, with the new keywords from our external knowledge base, which is FrameNet, and that's by applying or employing this supervision. After that, we gather tweets using hashtags and geolocations related to the event. So, for example, if we want to gather unlabeled tweets from Riyadh earthquake, then we will use hashtags such as pray for Riyadh and then, of course, the geolocation of Riyadh. After gathering the label tweets, we then automatically label the tweet. So if the tweet has two keywords from the expanded keyword list, then the tweet will be labeled as related. Um, and of course, using two keywords will help in reducing the noise in the tweet. Um, the noise in our framework. And if the tweet does not have any keywords from the expanded keyword list, then it will be labeled as not related tweet. At the end, we got a range of labeled tweets from Riyadh earthquake. So let's get inside the stage where we employ the data supervision. So framework is an external linguistic knowledge base for English that has more than 1,000 semantic frames that have more than 100,000 lexical units. So here in our example, if you can see, we have moving in place. Moving in place is a frame, and the frame has been associated with many lexical units such as shake, rotate, earthquake, and so on. So in our work, lexical units can be used as keywords that evoke the crisis type. In our example, the crisis type is earthquake. And if one of the sub-crisis type keywords exists as lexical unit of a frame in the FrameNet, then this supervision assumes that all the lexical units related to the given frame express that crisis type. So in our example, earthquake in red is one of the keywords from the top key keyword list. And because it exists in the FrameNet and it has been associated with moving in place, the frame moving in place, so we assume that all the lexical units, such as shake, rotate, wave, also express the crisis type earthquake. So we add them to the list, and as a result, we got the expanded keyword list. So we raise up two research questions. The first question is we ask ourselves if we can automatically generate labeled training data for tweet classification for crisis response that has a competitive quality level compared to manually labeled training data. The other question is when added to the available label data, does our automatically generated label data improve the performance for the class-related tweet classifier? So we actually asking ourselves, can we produce a good quality automatically labeled data? And if we can do that, does adding them to the available training data improve the performance? So to answer our research question, we run two groups of experiments. The first group to examine the quality of the produced data, and the second group is to investigate the effect of adding recent data generated by our framework to the available manual label data. So in our experiment, we use the same configuration, model configuration. So we use BioSTM and CNN, which is the best reported deep learning architecture, according to one of our previous work. We also clean all the tweets. We remove the hashtags, the user mentions, some of the tweets specific words such as via and RT. Um, and we use also a pre-trained word embedding, the 100-dimensional glob embedding. We also initialize the hyperparametering according to one of the works in the literature. We fine-tune the word embedding, but not the hyperparameters. We also use drop outliers to avoid overfitting. To evaluate our work, we use weighted F1 score. We run the experiment 30 times, and we use the average as our final F1 score. So in the group one experiment, we use two kinds of data sets. The first one is the available label data uh, um, from Crisis NLP. So the tweets in Crisis NLP has been labeled in 7 classes. However, we relabeled them into related and not related because classes because our task is a binary classification task. And we also use Crisis Lix T26, Crisis Lix 26. This suite has been already labeled in related and not related classes. The other side is the available unlabeled data. So they provide the IDs. So Crisis NLP provides the ID of the tweet, and we retrieve the text using those IDs. So as you can see in the first table, we have the manual label data for 3 crisis types: earthquake, floods, and typhoon. And in the second table, we have the unlabeled data for 3 events from 3 different crisis types. So we have Pakistan earthquake, Pakistan flood, and Hataybat typhoon. So the goal of the group one experiment is to investigate the quality of the labeled data generated by our framework comparing to the manually labeled data from the same event. To do that, we run 2 sub-experiments for each process type. So in the first experiment, we use the manually labeled data. So for example, for the Pakistan earthquake, we use MTE, which is the manually Pakistan earthquake data. And in the second group, we use the automatically labeled data. So instead of Pakistan manually labeled Pakistan earthquake data, we use the automatically labeled Pakistan earthquake data. So instead of MTE, we use APE to just compare between the manually and the automatically labeled data from the same event. So these are the results. For earthquake events, we can see we use APE, which is automatically labeled data for Pakistan events, for Pakistan earthquake, instead of manually labeled data for Pakistan events to train the tweet classifier. The performance slightly drops. So we can see here that it drops. So in the table number 3, we can see that for Chile earthquake, it drops for to some 2 percentage. Um, and here in the Nepal earthquake, we can see that the difference is very small, so less than 1%. Um, in the flood events, we use automatically labeled data from Pakistan flood instead of the manually labeled data of Pakistan flood. We can see that the maximum drop is in the MAS, sorry, and this is the Alberta flood, and the drop was 4.2, which is less than 5%. For typhoon events, we use the automatically Hakibet typhoon event data instead of the manually Hakibet typhoon data. Also, it has a very small impact on the performance, but however, this is not the case for MST. MST is the manually labeled data from Sydney typhoon, and you can see that the difference is very, very, very high, more than 5.5%, around 7 point something percent, and this is because the Sydney typhoon tweets are very similar to the original training data. So to answer our first question, we can see that in general, substituting automatically labeled data produced by our framework with manually labeled data from the same crisis events in the training tweet classifier for disaster response has a small impact on the classifier's performance for the three crisis types, which is earthquake, flood, and event. And I mean by a very small impact, which is a drop of less than 5%. So this is in 13 datasets out of 14 datasets. And this is because the difference in the performance is actually very small. So we can say that they have a competitive or a comparable quality level. In the group two experiments, we use two kinds of datasets. Uh, so the first one is the available label data, which we use in the group one experiment. And the second one is the collected unlabeled data from three recent crisis events. So we collected using Twitter API. We use the geolocation of the sound and the important hashtags, as we said in the other way. We use our framework to label all the collected data. So we use our framework to label those. So as you can see, we have the Indonesia earthquake, the Texas flood, and also the Indonesia typhoon. And those are the events from 2019. And we labeled them. Why we use those numbers? Why we labeled exactly 1,500 tweets for Texas flood? Well, this is because if we go back to the original one, we can see that for the flood, 1,500 is very similar to the number of the manually labeled data that we have for flood events. So that's why, because we add all the tweets and we get the average for them. So we divided them by the number of the events to get the mean the average of the number of the tweets that we can produce for our recent event. So the goal of the group two experiment is to show the effectiveness of incorporating recent label data generated by our framework on the performance of the treaty classification model for crisis response. So we compare three labeling methods that give labels to the unlabeled tweets from the recent events. So the first one is the pseudo labeling, where similar manual label collection from the same crisis type were used to pre-train the model to be then used to label the recent unlabeled data. And this is very similar to one of the work in the literature. The other one is our work, which is the Distance Supervision Based Framework, DS, where our framework was used. And the third one is the DS without framework. So we just want to see what is the impact of using framework, where of course the step three was removed, where we employed the distance supervision. And we compared that with original OG, where no new data is added to the original training data. So there is no labeling method. So those are the results. So in the earthquake events, we can see that our work, DS, reports the best labeling method for two earthquake events out of 5. And for the others, which is the three remaining datasets, the performance does not improve. So you can see here that so here DS is the best, and also here DS is the best. But for the other three, OG, which is using the original training data without any new added tweaks, is the best. Is the best model. So yeah, it has a very very small improvement in the performance. For flood events, DS is the best for four crisis events out of five, and CD labeling is is better than DS in one data set, which is the Pakistan flood. So we can see here that DS is the best um, for crisis events, and um, but DL is the best for Pakistan flood. However, the 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 improvement is very 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 small. So as you can see here, the improvement is like I don't know 0.01, less than 0.01, and here the improvement is very very small as well. Here also the improvement is very very small, less than 1%, and the same thing here. So the improvement is very, very minor. It is the same case for Python events. So this is the best labeling method for 3 out of 6 datasets. Um, However, the performance does not improve for Oklahoma and Sydney Typhon data. Also, BL is the best method for Odile Typhon. And also we can see here that the performance um, the performance is not improving that well. So all of them are like less than 1%. So after analyzing the data, we observed that if more than 7 keywords from top key keyword list appear in the test dataset, then DS is the best labeling method. And that's because it provides new keywords from framework to the training data. And these new keywords assist in recognizing related tweets that would not be identified by the old keyword list. And also multiple new relations may emerge when you use these new keywords. In the other case, if the number of new keywords removed from the framework is limited, then adding data from new crisis events does not improve the model's performance, regardless of the number of the sub key keywords appear in the test data. The other scenario is if the train and the test data are similar and the number of matched keywords is low, then BCD labeling is the best labeling method, of course, because the similarity between the test and the training data overcomes the new keywords driven by frameness. So to answer the second research question, we can say that in general, there is no big improvement in the model performance when adding the arithmetically labeled data produced by neither any of the three labeling methods to the original manually labeled training data. So to sum up, we investigate the application of distance supervision in generating automatically labeled data from new crisis events, and this helps to overcome the problem of reduced generalization levels of the current crisis-related classifiers, and of course, that leads to a more reliable system that can be used by humanitarian organizations to help people in need during crisis. Also, the results show the effectiveness of our distance supervision-based framework in producing labeled training data from new events. Of course, this indicates that the generated data has a very competitive quality compared to the manual label data, with less effort, money, and time, and can be used when no manual label data is available. Results also suggest that our proposed framework is the best labeling method when the test and the trained data are dissimilar. And that's because it recognizes the related tweets in the test data that include the new keywords retrieved from FrameNet and do not exist in the original training data. However, adding these tweets to the previously available manually labeled tweets and training the classifiers did not uh, have a very big improvement in the performance. So and we want to say that more future experiments are needed to examine the effectiveness of adding automatically annotated data from two crisis events instead of one. And this is to cover the gap in the tweet number between the manually and automatically labeled data. And in the future, we are planning to use our framework to generate datasets for crisis types that have only one or two manually labeled data, such as building collapse um, such as building collapse and volcano and so on. So these are our references, and this is the end of our presentation. Thank you for listening, and if you have any questions, please let me know.